Thank you. Thank you very much. I understand it's customary for me to say that I'm the only thing standing between you and your lunch. But I also hope that this presentation is just one thing standing in between you and writing much more useful and more beautiful tests. So quick, who am I? I've been in the software industry for nearly 30 years now. Started off in C++, and I was very fortunate to be working for a Formula One company. Since then, I jumped over to starting to use Python about 20 years ago. I've worked in medical devices, mine site, heavy equipment training, even worked on a flying car. I don't know if that's still flying or not. Last time I checked. I'm currently working for a on-demand transportation company called Truck over in Australia. And that's where I've sampled some of the code that I'll be showing you today. I do write a blog on my experiences in delivering software, and I'll have a QR code up to that at the end of the presentation. So why am I talking about beautiful tests? So I joined Truck basically when it just launched its MVP, and it had pretty much no testing. I felt it was my job to start bring some best practice as they went from small startup to now national company. And in the process, I checked yesterday, and we now have over 3,500 tests. But when you're writing tests, especially when you're under a little bit of pressure, this usually is usually your workflow. It's like, okay, got some new feature, how on earth do I test this? And you hack away, and then you just like, okay, I just want the test to pass. But in my experience, it happened many, many times, is that you read your own test 1 year later, and you're like, who the heck wrote this? This is terrible. I don't know what it's actually testing. So these are a few lessons that I discovered, and I'd like to share them with you today. So one thing I understood is not only are your tests there for functionality, to test the functionality of your code, but they're also there to express an intent. The intent usually comes from your user, your product owner. And it's really important, I found, to make sure that your test actually communicates that intent as well as proving that your software works. We have over 3,500 tests, which might seem like a lot of quantity, but quantity does not always equal quality. And just as I explained earlier, many, many times I've revisited some of my old tests, and it's taken me much longer than I wanted to actually understand what that was testing when something has gone wrong. So your tests are, in fact, just another type of documentation. And your tests have audiences. And the most important lesson I've heard is not only is your audience you when you're writing them, make sure that your code is actually working. Your audience are your other team members, your other developers, and also the future you. If you're reading your tests and you think, if I looked at this test in 6 months' time, would I actually understand what's going on? But you can expand your audience. You can also, I often show some of our tests to our product owner, and he can actually understand them, which is a major benefit. So unreadability, I think, is a big liability in the testing world. Just to clarify, in this talk, it's fairly high level. I won't be addressing things like performance and speed, test coverage, using certain types of frameworks. So it's a fairly high level talk. So if the purpose is to write beautiful tests, then what is an ugly test? So I came up with these reasons. So ugly tests they're a puzzle, right? They're difficult to understand. When you read them, I talked about intent, and you struggle to understand what was the intent of this when I actually wrote this. They can sometimes cover multiple test cases in one function, and also importantly, when a test fails, it's very hard to understand what's actually gone wrong. So they're mysterious as well. They're not overt. They're covert. They kind of hide what that intent is. And the reason is that quite often we like to take shortcuts and we break into our internal design, which we know just because we're trying to get the functionality to pass. And a side effect of this is this makes them brittle as well. So we can be using too many mocks, we can refactor our code and then our test break. Even I found changing the order in which your tests run can actually break. I really like this quote from Kent Beck. I guess in a nutshell, you're writing tests for a reader, not just for the computer. So once again, you're writing tests. When you're making them pass, you're writing them for the computer, but when you're communicating that intent, you're writing them for other people as well. So here's an example. This is an old test that I dug up from our code base. It might look good when it's up on the screen, but let's have a look at what's wrong. So first of all, we start off with a mysterious patch. I mean, sometimes we've got patches that I don't know. So what's this patching? Why is it patching it? We've got some authentication, but it's not actually. There's a mismatch in the comment on the code. It's like, is there actually some authentication happening, or has it already happened? Then we jump into internally accessing our model structure. So we're breaking some encapsulation there. We've got more internal access model. This time we're using an ORM to access our database. Here's the authentication. All right, so there's the mismatch. We've got more unknown mock manipulations, more mysterious patching. But the most important thing down the bottom is, what is this actually testing? I mean, what is the assert actually doing? What's the intent? So we're going to give your test a makeover now. I came up with 7 things. The first 4 things I think should be fairly basic. Most of us in the room, I think, should be doing this already. And then I'll dive into some more specific things. But overall, right, the overall theme is just make things obvious. So simplicity, we've heard this a lot. Make one test, just do one thing. Don't overcomplicate. Don't cram loads of tests. I've been guilty of this. I've been guilty of pretty much everything that is up in this presentation. And I've gone back to tests and like, oh my God, this test is testing like 4 different things. And when the test fails, you've then got, well, which of those 4 things is actually failing? Doing this immediately reduces your brittleness in your testing. So this is one pretty much golden rule that everyone should be doing. Naming. Naming is one of the hardest things in software development. Some tips: try and make your tests tell a story. So, for example, on the left, on the right, we've got a test function called test driver list. We're in the transportation domain, so this will be a lot of transportation type testing. We don't really know what that's testing. It could be testing a number of things. Better would be test that drivers cannot see banned driver list. Avoid magic numbers. I mean, this is just like writing normal code, you know. If you see an assert result.answer equals 42, you don't really know what that means. Much better is assert result.answer equals the meaning of life. Okay, now you have some context of what you're actually testing. Ordering. Again, this is quite simple. Just try and order your tests. I asked ChatGPT for this, and it came up with the 3 A's. Arrange, act, and assert. So arrange your tests at the start, set up your context, set up your starting state, then act on your system, and then finally assert that your outcome is what you expect. And my 4th simple rule is something that I find many people overlook, and I'm always pulling up my team on this, is communicate fairly well. If something goes wrong, try and explain what happened. Don't just let the computer print out, 1 does not equal 2. Who knows what that means? Instead, I expected 2 matching jobs, but I only found 1. Another one, look up, something's not found in a dictionary, key error racks. Much more useful. I expected racks to be in the equipment list for this truck. Now you've got a much better chance of actually diving in your code and working out what's wrong. I'm going to have a little AI pit stop here. After these 4 little tips, what I found, I've been using AI a lot to help me write and check tests. AI is really good at evaluating a set of rules on your existing code. So you can actually code these rules up, and there's an example here that I've used a few times. So I've highlighted the simplicity rule, naming rule, ordering rule, understanding failures. You can give AI simple instructions like this, and it's actually really effective in spitting out, you might not like what it finds, but it'll spit out some tips to say, this function, it's not very simple, or the ordering's mixed up, or the failure cases are not well explained. So now, dive into testing domain language. I like to think I came across this myself, but after I started writing a domain language model for our tests, I found many videos by Dave Farley that have already documenting this, so I can recommend looking up Dave Farley's stuff. But basically using story elements and a common business level language for your tests. I really like, I got my inspiration from the JavaScript testing library, I think it's called Mocha, which uses object chaining to create almost English readable sentences. So when I set out to make our version, I really wanted to get that English readable. So for example, at the top we've got user.login, user and password, and then assert that the response code is 200. Now these are very low-level things. Devs will understand them, but there's also a chance that maybe new devs won't. So much better is write a function such as given a logged-in user with your username, and then the user can see their profile, actually test that thing, and once again you're expressing the intent of the test, not the low-level mechanics. Even better, using object chaining, you can create whole libraries of these things, and say, for example, given.user, the test user is logged in, then test user can see their profile. And you can do things like can see, you can split that up into different functions, so you can see their profile, can see their outstanding credit, can see their job history. A little bit of a deep dive into here. So I mentioned already that using object chaining is really good for creating those kind of English level sentences. So I've got an example on the right hand side of what our domain level testing class actually looks like. But the key thing is that you're abstracting away from your implementation, and you can design your language to talk exactly the way that you, your team, and your business talks. So we have a concept of shippers. You might have a concept of users or customers. We sometimes use is authenticated or is logged in. You can use your own domain language that you are familiar with. But you also have to balance this a little bit with flexibility. We've found that you can't really do everything. Not everything comes out looking like a perfect sentence. You have to make a few compromises here and there. Some methods we have, for example, in the when class, you can see the shipper basically does nothing. And that's really just for syntax. That's just to keep the readability going. So it assumes you've already logged the shipper in, and it's just for keeping that expressiveness. So the highest level that I found, the next step up, is BDD, or using Gherkin. And this is the most expressive you can be. We're using this a lot in InstaTruck. So an example here is given a job is assigned to Dave the driver, and the job requires stairwell access. And stairwell access includes a driver notification. When Dave accepts the job, then there's an SMS. It is sent to Dave saying, "Hi Dave, your next job requires stairwell access." Very easy. We have started to use this more and more in our testing. We use PyTest BDD, which it's got a little bit of a learning curve, but I can recommend it. And the key things here is that you're focusing on the what. You're focusing on the outcome of what that system behavior actually is, and not the how. So all your language is oriented around your users and the interactions, not what's happening under the hood. And they're the perfect way of linking what your business wants to what your system is actually doing. So I highly recommend experimenting with BDD and Gherkin. Another AI pit stop. I've had less success with this. We have a couple of ChatGPT assistants which we use to try and convert our user stories and rules into Gherkin scenarios. Sometimes they work, sometimes they don't. The tips I can give is you have to be very explicit. We've found in what the purpose of your system is, who your users are, and what your domain language is. So I mentioned earlier about the expressiveness of your domain language. You really have to tell ChatGPT or whatever your client of choice is what that language is. Otherwise, it just goes off and makes all kinds of assumptions. So we've had, like I say, we've had much more success using AI in checking your existing tests, or maybe a test that you've just written against a set of rules that you want to enforce, rather than generating tests by itself. We're currently experimenting with feeding our domain language into ChatGPT. and giving it our scenarios and saying, hey, can you write the test for us? So that's currently a work in progress. But I'd love to talk to anyone afterwards who's doing something similar. And finally, we talked about expressiveness and intent. I find that the most useful tool and most kind of highest ROI that we've had is simply parameterizing your tests. If you can set your tests up with a library like parameterized, or PyTest has its own parameterization built in, you can make these beautiful tables, and the intent really comes kind of built in with those tables. Everyone's used to looking at tables, so you know what the input to the system is, what the expected outputs are. And when I see tests like this from my team, I very rarely have to look at the code. You just say, okay, I know what the inputs are, what the outputs are, I know what this is actually testing, and if it's passing, I'm happy. So another quote from Kent Beck, use data that makes the test easy to read and follow, and this is exactly, I found, the best way to use that data. So here's our old test again, with our mysterious patches and our internal access. So can we apply what we've learnt to this test and make it better? Of course we can. So this is what that test looks like now. You can see that we use the given, when, then. We've got our setup at the start. So given and authorized logged in user. We even got a new criteria now. Given the driver has device iOS, so we run tests for iPhone and Android. Given the job is assigned to that driver, given the truck feature Rex has notified driver is true. This one is not, fully an English sentence, but it's still immediately understandable. Then we have to do, we can't do everything perfectly this way, so using a context manager here, but it's still English kind of readable with the push messaging system. Then when the driver accepts the job, the system responds with success, and this is my favorite. When I finally got this working, I was so happy, because it literally says, then a push notification is sent to the driver with this message. So that is your intent. If I'm reviewing tests and I just look at the last line, I know exactly what it's doing. I didn't have room on the slide to put parameterization, but under the devices, the iOS and the truck feature racks, we could parameterize this and make it even more readable. So how do you get to beautiful tests? I hope I've convinced you here that beautiful tests are possible. I think they really improve developer productivity and team collaboration. Like I mentioned, I've even shown our actual test code to our product owner, and he has understood it. I find as a code reviewer that my life is much easier reading tests like this, and you just really have to make them a habit. Just do something every day. I really like this graphic. You might, hopefully you've also got thousands of tests, but no matter how hard it looks, there's always a start. You can always just start with one. Show your team, show your colleagues, and hopefully you'll gather some momentum, and soon everyone will be doing it. So I initially wrote this talk for a Thursday night meetup. So I finish off with, pick one test tomorrow and make it a little bit more beautiful, but I fully expect everyone will be here tomorrow and not coding. So pick one test on Monday and just make it that little bit more beautiful. I made this presentation based on a couple of blogs that I wrote over on my blog. My QR code is up there if you want to have a little bit more of a deep dive into that. But thank you very much.
Thanks so much, Richard. I certainly was re-enlightened about my tests. I really resonated with the idea of tests as documentation, and that was furthered by your example of refactoring one of your tests into a very readable format. So really love to see that. Awesome stuff, Richard. Now we do have a little bit of time for questions, so I'm looking out for some questions. We'll have a mic moving around. Let's start here in the middle, in the red, please. There we go.
No problem. Okay. 2 questions. Thank you. You didn't cover much about test-driven development. I'm very curious to learn about your take on that. Second question, generalization. When you grab the test cases, would you aim for the don't repeat yourself principle, or would you rather generalize tests so you minimize code? Do you have any take? I have this kind of experience where you end up generalizing tests and you sacrifice readiness and documentation, using tests as documentation because you want to make the test elegant. Anyway, I'm very curious to learn your takes about both topics.
Yep.
Thank you.
So TDD, I love TDD. I've been using TDD a lot. I find that doing something like this really helps TDD, and I think it has actually helped my team. They were really struggling with TDD because we were doing those bad habits of kind of, writing tests based on what your implementation is. Once we've switched to this method, I find TDD is much easier because you can pretty much write the test straight from the behavior specs. So it should actually grease those wheels a bit and make that experience a lot more fluid. For the repeating stuff, because if you write your own domain level test language, you're already taking out a lot of that repetition. So you might have some of those procedures we had in there, like assigning equipment to drivers. Some of those are quite complicated, and it's much better to just. I don't mind repeating the single statement, such as given this equipment is assigned to this truck, because it carries the intent with it, and you've already abstracted away how you get to that state. So you're doing away with a lot of duplication. But I think keeping that intent in the test is actually a good thing.
Thank you.
Fantastic. Another question right at the back there with the black hat, please.
Alrighty. Testing. So with thank you for the talk. Very much agree with on the table-driven tests. There's one thing I want to challenge you on and kind of want to hear. Yes. What's the balance between having a code that is your the abstraction layer that allows you to have nice English-sounding stuff, but might not be as direct in terms of, hey, it says it's asserting this thing, but you actually have to dig into it to make sure that the test is actually asserting rather than just passing. And if you want to make easy things to construct your objects, why isn't that in the main library? Why do you have to build a separate abstraction that's only used for tests and you might need to test yourself?
Yeah, that's a great question. One thing that we did actually find is as we built up our domain library, we actually discovered things that we were making that we could actually use in our production code. So that kind of level of abstraction was so useful that now we're at a stage where we could actually take some of those. Also, the previous question talking about duplication, we could actually fix some of our duplication problems with taking our domain level setup and putting it in our production code. So yeah, you could do that. And for your first point, just remind me what your first point again was.
Making sure that the testing abstractions is actually valid.
Yeah.
And doesn't actually cause additional overhead, for instance, when you're debugging it.
Yeah. So it does mean that you do have a little bit of extra workload because your testing framework, your domain testing framework, is more code, and we do have to review that and make sure that it's working as expected. But in my opinion, we just get so much benefit and so much reuse and so many other readability benefits that's a very acceptable overhead for us.
Yeah, great answer to a tricky question. We might have time for one more quick one. Let's go here in the front.
Let me just run around the venue.
Sorry, I made you jog all the way across the room for that one. Great.
Looks great. Thanks for the talk. More in the weeds, the parameterized matrix testing that you demonstrated. Couple of things about that. Are they all green path tests? Because how do you specify? They seem to be scenarios that you're specifying there.
Yeah. So the top example, they're all green path tests. Those are all price calculations. The bottom one is both. So some of the weeds, we don't really have a convention. It depends how much more work there is in asserting both types of path. If there's not much work, then we'll just put it in a table with a bunch of trues and falses, because I find it's more easy to express the intent when it's all together in one place.
So that's the assertion there, the true and false, in that last one?
Yes, if we expect it to be present or not present. We do have some parameterizations which are for expecting exceptions to be raised and things like that. So it kind of depends. I try to put intent first, and if you get more benefit from the intent than over a little bit more extra work in your testing function, then that's my priority. If it's a little bit harder, then we will have one test for happy path and one test for the bad path.
Fantastic. Thanks so much, Richard. That's it for time for us, guys. So let's give one more round of applause for Richard Forshaw. Thank you very much.
Thank you.